Hi everyone, you're welcome to Explore Insight. In this video, I'm going to teach you on how to find the number of bits required to represent a number. This is typically solution to binary number problems. If you're just joining us for the first time, please do well to subscribe to this channel and don't forget to hit the like button. So without any further ado, let's get started with a question. So in this question, we have how many bits are required to represent the following decimal numbers. So we want to check how many bits for what we have from A to H. So I'm going to take you on with two methods, the simple method and the other way. So let's see how fast we can solve this with both methods. So please stay relaxed. So let's start with the first method. So for the first method, all we need to do is to draw out a table. Even if you are going to be in the exam hall, it's pretty easy to do that in few seconds. So when we do that, we are going to have the bits, and the bits runs from 1, 2, 3, 4, 5, 6, 7, 8, and so on. Now, how do we know the maximum number from the bits? Now, all we need to do is to go with this formula, 2n minus 1. Now, when our n is 1, logically, the maximum number is going to be 1. Check out, when n is 2, we're going to have the maximum number as 3. When n is 3, we're going to have the maximum number as 7, and so on. So if the bit is 8, we are going to have the maximum number to be 255. Recall, we are asked to find the numbers of bits that is required to represent certain decimal numbers. So let's start with 5, which is A. All we need to do is to bring out the first problem, which is A. So now we have A. Now for A in base 10, we are going to look at for the maximum, the number of bits. So first of all, take a look at the table and look what will typically be the bits to represent it. So let's go down here, which talks about the maximum number. Now, can we find 5 here? Definitely no. So it means that we can locate 5 between 3 and 7. Yeah, we can get 5. Now, since we can get 5 here, so it literally means that we are going to go with the highest bit because we are looking for the maximum bit. So we are not going to settle with 2 because the maximum number for this is 3. It means 5 cannot be located here. Rather, we go for the next bit, which is 3. Because in 7, we can locate 5. So to this end, in this question, our bit is going to be 3 bits for the decimal number 5. Now let's look at the other method, which is method 2. In this method 2, I'm going to introduce what I call the log 10. So we are going to equate that as 2 raised to the power n equals to 5. What is n? N is just the number of bits which we are looking for in this problem. Now, as we're going to introduce that, we're going to bring our n to be the subject of the formula, which we can see here. And here we have log 10 of 5 and log 10 of 2. Now, if we check for log 10, log 2, we are going to have 0.3, and that's for this one, we're going to have 0.698. So you can just punch your calculator to verify this information. And if we go through the division, we're going to have 2.3. Now let me tell you something. In this scenario, we are only going for the maximum bits. As long as it has decimal points, we will look up for the maximum bits. So to this end, we are going to approximate this up, and this will give us 3 bits. So these 3 bits in method 2 is equivalent to the easy method in method 1. So pretty easy. So let's see for others. So in this case, we want to look for 10. We'll be looking for 10, 15, and others. So let's look at 10. So for 10, let's go through the method 1, which is pretty easy. Let's locate 10. In this maximum number, where can we see 10? I think it falls between 7 and 15. So we cannot go less, which is 7. We just have to move to 10. And with 10, we can consider the bits, the number of bits to be 4. This is why typically we have the bits to be 4. And if we are to follow method 2, yes, for method 2, the same way of applying log, for apply log, we are going to have log 10, and also we are going to have this. Now, if we divide this for log 10, we are going to have 1, and this is 0.3. So this will give us 3.33. Like I said, you round it up. If we round it up, we are going to have 4 bits. So let's look at others example. So for C, we have 15. So it's going to be 4 bits, because if we look at this table here, the maximum number is 15. So definitely our 15 is located here. So our number of bits is going to be 4 bits. The same thing for apply log. We're going to have, in this scenario, we're going to have 1.176 divided by 0.3. So we are going to have 3.92. Approximate it up, we're going to have 4 bits. Now let's move over to the next one, because most of you like us solving all the examples we show out on our channel. So permit me as I take you through all the solutions. Yes, so for D, we are going to have 20. For 20, we want to find how many numbers of bits we're going to have. So let's look at this table, which is the method 1. Now, can we locate 20 here? No, it's just between 15 and 31. So if we go for the highest value, which is 31, it means that the number of bits is going to be 5 bits for decimal number 10. Okay, so let's look at method 2. We have 2n equals to 20. While we introduce the log, we're going to have 1.301 divided by 0.3. You can see the 0.3 is just fixed here because we're working with log 10. So if we divide this, we're going to have 4.34. If we round it up, it's going to be 5 bits. Now let's go to the next one, which is for 100. Now for 100, we are going to check through with the table also. So where can we locate 100? Now we can locate 100 within this value. Yeah, so the maximum value here is 127. We cannot go less, which is 63. So we'll look up to this. And the number of bits will be 7. So literally, if we go by the log method, we are going to have 2 divided by 0.3, which will give us 6.66. If we approximate it, that's 7 bits. So this is the same. Method 1 and method 2, the same. So the same thing, just to keep the time short and not to make this video very lengthy. So let's see. For F, G, and H, I'm just going to use the method 1. And for 120, you can confirm that definitely we're going to have 7 bits. For G, which is 140, we're going to have 8 bits. And for 160, we're going to have 8 bits also. How do we confirm that for 140 and 160? Let me show you also on the table. So for 140, the less number here is 127, so that's less for 140 and 160. So we have to look up to the next maximum number, and in this case we're going to use the bit here, which is 8. So I hope you're able to understand this phase of my topic based on how to find the number of bits required to represent a number. So this is one of the binary problems which students face. Please don't forget to hit the like and subscribe to this channel. Tell a friend to tell a friend to subscribe to this channel. Thank you for watching. Remember, mathematics is not hard and digital electronics is not also hard. Just give it time to study and be patient about it, and you'll get through with it. So have a good time. Bye.